Welcome to the Ricci Flow Nutrition Podcast. My name is Cameron Borg. On this episode, I had the pleasure of speaking with Clark Engelbert for the second time. Clark is a health practitioner who specialises in mineral balancing. The concept of mineral balancing is based on the field of ionomics and stems from the work of a soil scientist, William Albrecht. Clark is particularly interested in the use of hair tissue mineral analysis, or HTMA, in identifying system-wide nutrient relationships in order to restore balance and eliminate accumulated heavy metals. The use of HTMA over blood analysis gives some salient advantages in some respects. For one, hair is a tissue sample and can be used to gain deeper insight into the longer-term status of an individual and their metabolic function. While it has its limitations, HTMA, when interpreted correctly, can be extremely helpful in identifying imbalances in the mineral system and establishing protocols to rebalance that system. Clark currently runs nutritional analytics, where he works with patients from all over the world to help them deal with heavy metal toxicity and mineral imbalances that are ubiquitous today. With all this being said, I hope you enjoy the episode. All right, Clark, it's really good to see you again. It's been a while since we spoke last, but I've been thinking about this idea of what you're doing with mineral balancing for quite some time. It's always on my mind. And I was reading a paper the other day, and I'm going to quote it because I'll ramble on for too long if I don't get right to the point. And it says, an important feature of systems-based thinking is its focus on relationships rather than individual variables. Systems-based thinking regarding metabolism focuses not on the levels of metabolites, but instead their relative quantities, ratios, and patterns that can be detected within the ocean of 1,000 metabolites. And to me, this is really at the core of what you're doing with mineral balancing, is focusing on a level of organization that is much deeper and more foundational than biochemistry. You are looking at the complex relationships between all of these things from a higher level. And I think what biochemistry is doing is it's analogous to trying to understand what a house looks like just by looking at a single brick. And you'll never be able to know what the house looks like based on the brick. And what HTMA and mineral balancing seems to be doing is stepping back from this biochemical model and looking at a systems-based model, looking at the relationships between the minerals that basically make up what we are. And you know, we were just talking before I hit record about, and you brought this up, not even me, and I knew this was going to be the first thing I was asking you, was this systems-based approach, looking at the body from a more broad foundational perspective. And I think that's what mineral balancing is. So maybe you can elaborate on that and give a little bit of your insight into what you think systems-based approach should be.
Right. I think the first thing maybe that we can get into is defining what mineral balancing is. That can sort of lead us into this idea of systems-based thinking. But mineral balancing is essentially first the recognition that all of the elements inside of you, non-essential and essential, exist in a system. The implication of this idea, which is not very well known, even to this day, the implication of this idea is that these elements all interact with each other within that system. And the interactions, more so than anything else, define mineral metabolism than just like an individual intake of an element in the diet, let's say. Okay, so understanding mineral balancing through the systems-based lens is really, really critical. That's the first piece of understanding what we're doing with this approach. But then it sort of becomes a question of, well, how do we measure the mineral system, right? Because measurement is very important in science and in health and healing. And we actually use a hair tissue mineral analysis to measure the whole system of elements, right? And then once we get that measurement, we use our knowledge of nutrient and mineral interactions specifically to balance the whole system. So the goal of mineral balancing is to balance the whole system of elements that we identify on the hair test, which is a specific way to measure the minerals in a tissue compartment. And then we seek to balance the system with our knowledge of nutrient and mineral interactions. And then the balancing of this system, it sort of begs the question, what occurs as a result of this balancing process? What occurs is that a lot of different things sort of come back online in the body because so many different immune and detoxification processes are dependent on all of these minerals and their not only sufficiency, but good balance, right? So a lot of antioxidant enzymes, metal binding proteins, your hormones and neurotransmitters are very much mineral dependent, but they drive a lot of these detoxification processes. And the idea is that as the minerals get balanced, you trigger elimination of the heavy metals because of this global effect on the detoxification and immune systems. So everything about mineral balancing, layer after layer after layer, is like this recognition of the mineral system. How do we measure the mineral system? How do we balance the mineral system? And then what happens as a result of that balancing? And so at the end of this chain of logic, we can kind of get into, well, heavy metals, right? And what's critical to understand about minerals and mineral balancing is that the end goal essentially is to detoxify your heavy metals. And layered within this, we have to go back to the mineral system component, which is that not only do minerals interact with each other, but heavy metals interact with the minerals in the broader mineral system. So we talked about this, I think, last time I was on, but we touched on ionic mimicry and this idea that metals gain access to cellular compartments in the first place through mineral channels and transporters, right? Metals interact with minerals, they get into your tissue compartments through mineral channels and transporters, and then they substitute for minerals on important enzymes and proteins in the body. And so when we do mineral balancing, we have to understand that the purpose of the balancing process is to, in some way, directly antagonize those heavy metals that have replaced the minerals in the first place.
So we're really talking about relationships rather than individual quantities, which I think is what blood tests, that's predominantly what they focus on, is individual quantities, whereas you're sort of stepping back and going, that's fine, we can use that, but it has to be nested within a deeper system of organization. And if you just focus on one thing at a time, what ends up happening is, you may correct one thing, but, 5 other things may have been put out of balance at the same time because you weren't focusing on this at the system level.
Right.
And you're talking about using HTMA, which is a very interesting test because, like you say, it is a biological tissue sample basically that you can get non-invasively, and it gives you essentially like a readout, like a story of the metabolism over the last 2-3 months ish, which is impossible to do on a blood test. You get a snapshot in time, and oftentimes the things that you're measuring on blood tests are so transient that might be completely different 5 or 6 hours after you test it. So the hair test has that advantage as well. And I'm wondering, how do we know this? I mean, this obviously comes back to Dr. Paul Eck, but how do we know what the ideal ratios are? There oftentimes in blood tests, there's a debate about what the reference ranges should be and where the optimal levels are. And how do we know that the optimal levels that we're given, those ranges on HTMA tests, are really what is ideal for us at all times?
Right. I do think that that's a valid question, right? Because how do you determine reference ranges in blood testing in the general population? You run a lot of blood tests on people and you do some statistical analyses, and usually the mean of that sets at least where we think the ideal should be.
Yep.
But that sort of approach is a little fraught with problems because the general population, the health of the general population has gone down so dramatically over the last 50 years that, even the reference ranges, if your blood levels are within a reference range, comparatively speaking to a population that's unhealthy, is that really valuable or a worthy measurement? That's an open question, I think, and up for debate. But the way that Paul Eck did this many years ago in the 70s and 80s is he tested a lot of healthy young athletes, I think upwards of about 10,000 of them in the Phoenix metro area over the course of about 5 to 10 years to establish the reference ranges. and the ideals, which he felt were extremely important. It's not really even just about the reference ranges per se, but the ideals are critical to understand in mineral balancing and when we use HTMA. But he basically measured healthy young athletes in the range of like, I think 20 to 28 years old. And a lot of these were elite athletes at like ASU, I think maybe even at the University of Arizona, and maybe NAU as well, which is the other university north of Phoenix. So he was doing his testing on people who were high performers. And so I think that's probably a better way to do it. Is it perfect? Maybe not, but I think doing it that way is probably a much saner approach than measuring, let's say the general population who, maybe in the 80s, certainly they might have been much healthier, but still, if you look at like, I've been looking at some interesting research looking at like measurements of pre-industrial man, the blood, or not the blood lead levels, but the bone lead levels of some skeletons of like Native American tribes in certain, in North America. They can estimate with some degree of certainty the lead concentration in skeletons from, I would say maybe 1700 or 1600s. Compare that to readings in like the 1990s of skeleton blood or the skeleton lead levels, and they're like 1,000 times different, right? So that's kind of just an interesting little tangent there, but yeah, I think that's a much better way to do it than, let's measure the general population and kind of hope for the best.
And again, you're not just looking to try and get everyone at that ideal point. You're looking at the relationships within those as well. And this hypothetical person that has the perfect ranges all the time, that that never exists. And people go through different things through their life, even month to month, that are going to cause stresses here and there that are going to cause shifts. So, from my understanding, you're not even looking to try and always have the ideal. It's more looking at the relationships and making sure that they're moving towards the right direction.
Right. Especially when we do retesting and we're trying to actually cause healing with this approach. It gets a bit counterintuitive and a little more in the weeds about how or what we're looking for in hair test interpretation, especially on retest analyses. But I think of, especially when we measure like the oxidation rate or metabolic rate on a hair test, and we can talk about what that means. There's deep connections between the hormones and the minerals, bidirectional relationships that define mineral metabolism in some sense as well. So it's not even just about the interactions, let's say, but the interactions are important. But understanding that many of your hormones regulate mineral metabolism in the tissues as well. So that's a very interesting idea. But where I'm going with this is that it's difficult to get to some sort of perfect ideal, right? But I would think of, especially on the oxidation rate front, I would think of that as like a very dynamic reading of the stress response. And especially when we really get into measuring sodium and potassium versus calcium and magnesium. And I think of this like in terms of heart rate variability, where the higher the variability, the healthier you are. The more that you can shift in between these oxidation states or metabolic states with more ease, the healthier you are, right? And the idea is that you want to have a very flexible metabolism to cycle between whenever you have external stressors, right? You want to be able to meet the demands of those stresses. And some of this is determined underlying the mineral balance, absolutely, heavy metal, the presence of heavy metals, presence of infections and other things. Certainly getting exposed to blue light is a huge risk factor nowadays for this. And I think a lot of people in the circadian space are expounding on how that works. But yeah, I think about this as in terms of like a very dynamic equilibrium where you want to be able to cycle in between, let's say, slow and fast oxidation very readily. But I would say for most healthy adults, you want to be in like what we call mild slow oxidation. And that's a little more parasympathetic state, but still quite balanced in terms of the oxidation rate.
Yeah, that's really interesting. That makes sense that you'd want that mild slow oxidation, but also want that flexibility because seasons change, and of course the environmental inputs are going to change throughout the year. So you want to be able to adjust to the and changing environmental inputs. And this is
Yes.
something I think a lot of people lack. And blue light is part of the story, probably because of the signaling that
Mm.
people are getting that it's summer all the time, and they lose that flexibility.
Right. Right.
Um, and maybe you can touch on some of the more common patterns that you see. There are a few sort of main patterns. You touched on slow and fast oxidation and broadly what that means.
Mhm.
And this came from, I think, Dr. George Watson back in, God, I'm not sure, it was at the 60s.
Yeah.
Um, and
Yeah.
yeah, maybe you could just touch on and elaborate a little bit on the main patterns that you see in people that you're working with.
Yeah, absolutely. So, what I would say is that Watson was trying to measure the oxidation rate or metabolic rate in the blood and using blood parameters and like pH. That was not a horrible way to do it, but the brilliance of Dr. Paul Eck, who is really like what we would call the founder or grandfather of mineral balancing, was that he came along in like the 70s and 80s and applied a lot of those ideas of Watson to very specific parameters on the hair mineral chart. And he was able to do this not only by understanding Watson's work, but understanding Cellier's work, Hans Cellier's work, and how many of your hormones actually regulate mineral metabolism. And specifically, when we talk about the oxidation rate or metabolic rate, things can get a little murky and nebulous. And so I want to try and define what that is for people here so they have some idea. But when we look at a hair test in the way that, Dr. Eck's interpretation approach, we tend to look at the first four elements on a hair test, which are calcium, magnesium, sodium, and potassium, very intently. And there's a couple reasons that we do this. Number one, those elements make up 99% of the mineral content in your body. So to that end, the body has evolved elaborate mechanisms for controlling the absorption and partitioning of those elements. Many of those underlying control mechanisms are hormonal in nature. So many of your stress hormones, thyroid hormone, parathyroid hormone, even insulin, and others are involved in regulating mineral metabolism. And so when we talk about the oxidation rate, it's really a measurement of the relative balance of sodium and potassium versus calcium and magnesium. And those two elements, they sort of oscillate together, but they oscillate in relationship to one another on like a seesaw. They're antagonistic to one another. But when we do a measurement of the oxidation rate, we're doing a relative measurement of those two sets of elements against each other. And we can kind of think of like sodium and potassium in this example as the gas on your metabolism. Calcium and magnesium are like the brakes. And so let's say, your sodium and potassium get very elevated, calcium, magnesium get very low. That's a good indicator that you're in a fight or flight situation. You're in the sympathetic nervous system, you're in fight or flight. And the stress hormones that are associated with sodium and potassium at the tissue level are elevated. And that's, what we call fast oxidation. Slow oxidation is the reverse, where we have high calcium and magnesium levels and low sodium and potassium levels. And that slows down. There's certain mechanisms that we can get into wherein like calcium is used by the body to desensitize the cells to thyroid hormone. Potassium is used to sensitize the cells to thyroid hormone.
Yep.
So very high calcium relative to potassium influences the rate at which thyroid hormone gets into the peripheral tissues. And the higher the calcium, the more difficult time thyroid hormone will have getting into the peripheral tissues. And so that's essentially what we call slow oxidation. That slows down your metabolic rate. And the cellular effect of thyroid and adrenal hormones are much lower, right? And then you end up with, common symptoms of slow oxidation might be chronic fatigue, any number of hypothyroid symptoms, low body temperature, poor circulation, fewer bowel movements, It's more of like a burnout trend in the endocrine system. And, we could probably do an entire show on the oxidation rate, but not only are there direct effects on those hormones, but those hormones are influencing detoxification pathways. To give an example, thyroid hormone sends signals to the liver to activate detoxifying enzymes and even ceruloplasmin, the main copper binding protein in the body. So if you have if you have this slow oxidation rate, high calcium and magnesium relative to sodium and potassium, that will slow down metabolism, but that will also affect your body's ability to detoxify. And then it will also affect your body's ability to absorb and utilize all of your other trace elements. So absorption and utilization dynamics for a lot of the other minerals are affected by the balance of the calcium and magnesium and sodium and potassium. And that was one of the most brilliant insights of Dr. Eck, is that the oxidation rate really has these direct effects in your day-to-day. But over time, if you get trapped in these patterns of slow oxidation or fast oxidation, utilization of all these other elements that we're measuring on the test and absorption will be impacted and lowered, essentially. And there's a lot of interesting literature looking at, say, absorption of zinc and iron in hypothyroid states, right? They know, a lot of endocrinologists know, women who have hypothyroidism, explicit hypothyroidism, don't absorb zinc and iron as well. And so they have these co-occurring imbalances that develop as a result of this imbalance in the oxidation rate.
That's so fascinating. I'll just make 2 points from my own experience. I'm one of those people that can eat whatever they want and never put on any weight. And I, of course, when I checked my when I did my hair analysis, of course, I'm in fast oxidation. And and recently I checked my mum. She was recently diagnosed with hypothyroidism, Hashimoto's hypothyroidism, and her calcium was literally off the charts.
Right.
And of course, that is exactly what you were just saying, that these minerals have direct effect on how well those hormones can actually exert their effect.
Yes.
So, and I really like how this work so brilliantly ties in Hans Selye's work, because again, he was a real systems thinker and tried to understand the body as a whole. And the fact that you can tie that in with what you're looking at on a HTMA and looking at the way that minerals impact hormones, for instance, is really interesting. It's quite parsimonious that it all sort of fits together like a jigsaw. One sort of relationship that I think I saw you post about this the other day is that the relationship between minerals and things like histamine intolerance. And we know, for instance, that copper is very important in the enzymes that degrade histamine in the gut, and copper and estrogen have a very important relationship. And I think this is tied into what happens during the menstrual cycle when estrogen is fluctuating quite a lot, and that affects the relationship between copper and zinc, which may leave some people at certain points in their cycle to be more histamine intolerant than others. And this sort of just shows the picture that all of these things are so intimately related, and trying to understand them at this level actually gives us an in to try and understand what we can do to help balance that system and prevent that from happening in the future.
Right. And copper and estrogen have a very intimate relationship. But it's not just copper. All of the heavy metals are estrogen mimics as well. So that's sort of an interesting idea, and may explain to some degree why there is such rampant estrogen dominance in women, but also in men nowadays, who, we're exposed to heavy metals at a higher rate than we've ever been throughout the course of our history. And going back to what we had talked about just a couple minutes ago with respect to those pre-industrial and post-industrial measurements of lead in skeletons, I think that speaks to that point very much as well. So yeah, the hormones, the hormonal piece, and the mineral relationships, it really sort of defines our interpretation approach that Dr. Eck laid out. And a lot of it comes from Watson, but a lot of it also comes from Salient, and the work that he did. And so, like, to give some specific examples here, on a hair tissue mineral analysis test, the sodium level correlates with the cellular effect of the hormone aldosterone. And that's because aldosterone regulates sodium in the tissues. The hair is a tissue test, right? So in some sense, this is where I think a lot of practitioners get confused. We're not measuring, there is sort of an influence on the intake in the diet that will appear in the hair eventually, but it's much more a measurement of these hormones that regulate these elements in the tissues. So aldosterone correlates to sodium, and cortisol correlates very well to potassium, right? So when we look at like sodium and potassium levels, it's much more a reading of the cellular effect of those hormones than it is like a measurement of direct intake of those elements in the diet. And that's where a lot of what I'll see in terms of, like, people recommending adrenal cocktails or other things, just take more sodium and potassium. When you have a low sodium and potassium on your hair test, that's not really sufficient to improve the condition of those hormones, which is really coming from the adrenals and obviously signaling mechanisms in the brain, which are very important, the HPA axis more broadly. That's another misconception in HTMA, that we're just like focused on the adrenals or whatever. Like, when it comes to measurement of sodium and potassium, yes, aldosterone and cortisol is what we're measuring the cellular effect of. But that there's a long chain of events that has to happen, starting in the brain, your perception of stress. Metals in certain brain regions can affect your perception of stress and lower activation threshold for the stress response. So that plays into this as well. But one thing I think we could get into that is very interesting is this idea of time cycles. Time cycles are not something that are very well known about in the alternative health space. The circadian biology people get it in terms of the 24-hour cycle. I think I try to talk about this quite a bit in terms of hair testing and like that 2 to 3 month window that we're measuring when we do a hair sample, right? But there's all of these different time cycles that exist in the body, anywhere from a millisecond to an hour to a couple hours a day, right? Your hormones oscillate on this cycle where cortisol and aldosterone are higher in the morning, right? And then later in the day, melatonin and other calming hormones are higher. So this idea of time cycles is very important to grasp because the minerals and the hormones oscillate along these time cycles as well. And there's some very interesting research done pretty recently. I think there was a paper I was reading from 2018 looking at not only measuring the relationships between the minerals, but measuring them over specific time cycles. And this was done looking at like copper and zinc in teeth, baby teeth that were shed from autistic kids. And they could predict with like 90% accuracy the rate of autism by looking at the zinc and copper ratio over these different time cycles. Like, because the teeth and the hair are sort of like a record of the deposition of these elements. So you can even do, sort of deeper analyses of the elements and correlate them with conditions when you understand how they oscillate over various time cycles. And this is where I think things are going in the future. Like, there's a circadian rhythm of zinc, right? And then there's a circadian rhythm of zinc and copper. And then there's another good example of a different time cycle would be the half-life of a metal. The half-life of a metal in the blood and then a half-life of a metal in your tissues could be different, right? And sometimes like the half-life of like cadmium or some other metal like lead could be 10 to 30 years, depending on the form and what tissue it gets deposited into. So this idea, though, of time cycles, I think, is going to give us sort of like another level of dimensionality to understanding or tracing back the pathogenesis of many diseases that people are dealing with. Because, like with your mom as an example, the calcium being very, very elevated on a hair test is an example of a very rapid loss of calcium through the hair tissue. And if that goes on for long enough, the calcium level will decline, right? And it will get very low. But so understanding the calcium level over this time cycle is sort of coming from X reading of Cellier, where calcium being lost and very high on a hair test equals mimicking a calcium deficiency state, but it's like an active loss. And then when that process declines, you actually end up with an overt deficiency state. So, and you end up with like 4 lows, and all 4 of like calcium, magnesium, sodium, potassium are low all at the same time. But this is very much related to the cycling of these elements and how these patterns exist over time. That's really where things get interesting, because then you can start to track back or trace or associate with a lot of accuracy, scary accuracy, the development of a variety of conditions.
This so perfectly matches Cellier's work, and even to an extent, Becker and Marino's work looking at the stress response from their rodent models to EMF. Initially there was this really large stress response, but then it sort of balanced out for a while. But then after a long enough period of time, that's when they really started to get the full effect after that period of adaptation, I think they called it. And this is essentially where the organism can no longer tolerate the effects. And I think this is what Henry Lindler actually made a really good. He was the guy who brought naturopathic medicine to America, and he made the case that there is a very clear distinction between organic disease and chronic disease. And organic disease is where the body is doing what it needs to do to reestablish homeostasis. But chronic disease is essentially where you reach the point where your body no longer has the resources to put it back into homeostasis and adapt. And that's when it becomes a chronic condition that cannot be overcome with the materials that the body has to work with at that time. And it's, like I said, it matches so well with what we know from a systems biology point of view, how these minerals interact with each other and essentially play this. That's like a big orchestra. They're all playing together, and each part is codependent on the next for it to work properly. And I think you mentioned at the beginning this idea of non-linearity, where even if you take a bunch of zinc as a supplement, it's not necessarily going to result in an elevated zinc on your hair test, because it's going into this infinitely complex system of the body. And then, Lord knows how many things are happening to it, and it's being regulated and controlled by countless other things. And, we don't know what's going to be spit out at the end. There's this idea of non-linearity. And I guess the like you said at the beginning, the big point is our exposure to heavy metals. I suspect the need for people like you doing this stuff would be much less if we weren't exposed to so many of these elements that we would have basically never been exposed to in any appreciable amounts in our evolutionary past. And, the lead that was used in fuel, that didn't just go away. It rested in the soil and in the ocean. Like, it's still there. And we're still getting trace amounts of it, every single day. It didn't go anywhere. They don't degrade. These are, elements. And like you said, the half-life of these is really long time. So what are the main sort of exposure vectors these days that people are really getting lots of these heavy metals through?
Wow, that we could do an entire show on. But I would say, generally speaking, processed foods are the most heinous culprit. Number one, tap water is a very big source of aluminum, as one example. They use aluminum as an antifungal agent in the water. So aluminum is useful in this regard that it can kill fungal microorganisms in the water, and that's good, right? But you're getting a small dose of aluminum in the water supply every time you drink tap water, or every time that you consume a food that is made with water, which is how many processed foods are made with this aluminum treated water? I mean, it's probably easier to think of all the foods that aren't made with that water. So processed food is number one. The water supply, number two. I think cosmetic products are a very big exposure vector, especially for women. Metals are this is something that people don't really know about metals, but they're extremely useful in industry and in agriculture and for domestic purposes. And they actually sustain, to some degree, civilization and civilizational processes. All of the, our TVs and our electronics use metals. The cars that we have are made from metals. Military equipment that we have are made from metals, like lead is used in munitions, right? And then different metals are used in, let's say, amalgam fillings. That's a big one that everyone sort of knows about. But metals are extraordinarily useful. And this is something that people are not aware of in terms of just assessing or understanding the ubiquity of these elements. If metals weren't useful, we would just be exposed to them like we were in the evolutionary context, and it wouldn't be a big deal. But because they're so useful, we are chronically exposed to them over and over and over. And the problem with them is that they're not biodegradable. So exposure is cumulative year over year. And we've been using metals for hundreds of years now to build and sustain civilization. So they're persistent in the environment because they don't biodegrade. And especially when they get into biological systems, that's where problems start, obviously, for humans. But that same property of non-biodegradability exists in human beings as well. And so, you have a half-life of some of these elements of 35 years. There's an isotope of nickel that has a half-life of 92 years, right? Wow. So best of luck with that.
Is nickel what's used in high fructose corn syrup?
That's actually mercury, but they use nickel to as a catalyst in the hydrogenation process for all of the trans fat.
Yeah.
So a lot of the problem with the metal exposure is that it's so ubiquitous. It's like you would have to halt civilizational processes if you were to really stop using them for all of these different purposes. Now, to not use them in like the water supply and in mercury amalgams or these obvious ones that we all sort of know about, that needs to be. And then certainly I don't know what we can say on here, but vaccines are a source of metals as well, and that's unfortunate because children being injected with those don't have strong defenses like adults do. So anyone who's interested in that, I would recommend looking into Chris Exley's work, famous aluminum researcher, one of the most famous in the world. He's published 300 papers on aluminum. But he's definitely established a link there. But the idea is that there's a certain level of ubiquity here, and no one is really aware of it. And so the delta here between these two things of what is happening and what people know about is so vast that I think raising awareness along these lines is probably one of the most important things that we can do to get the ball rolling back metal use and exposure where we can, right? But then also, I think people getting on mineral balancing and doing some other things in their lives that common sense things, practical things to avoid common exposure vectors, that's really, I think, where we need to start.
Absolutely. I'm not sure if we'll get cancelled for this or not, but I wanted to ask you about geoengineering.
Yes.
It seems quite clear that stuff is being put into the atmosphere, these salts of various kinds. I believe aluminium, bismuth, things of that nature, for purposes that I'm not exactly sure of. Is this something that you see is an issue, and if so, have you seen it show up in the clients that you're working with?
On the geoengineering front, I do think it is real, and I do think that they're using different elements to manipulate the weather. And you can do this, I think, with aluminum and maybe other elements to either block the sun or create conditions wherein maybe you have more rainfall as a result of certain elements in the atmosphere. But I'm not as concerned about that. Yes, that's real and that's happening, but I'm much more concerned about the known exposure vectors for metals in the air are infinitely higher, I think, than even
right.
geoengineering. And to give an example of this, there are certain point sources for metals. Metals are geogenic, and we're actually mining them all the time. We're mining minerals and metals, and they're then smelted or put through these factories where a lot of these elements are getting spewed into the air. And then these elements are being used in combustion processes for fossil fuels. So there are textbook chapters devoted just to air concentrations of metals around the world, and they can kind of do some modeling and measurements of this directly in specific regions. But like the mercury and lead and cadmium and aluminum content of the air in certain regions, especially more industrial that are in the developing world, is extraordinarily bad. China and India are two very notable examples there. This can matter for everyone in the world and becomes a global problem because the transport of metals in the atmosphere it happens very readily. So mercury, as an example, can exist in the atmosphere for up to a year. It gets changed into a different form. Sometimes it gets changed from elemental mercury into inorganic mercury. It gets rained down into the oceans, and that's where it's changed actually into methyl mercury by fungal microorganisms. So I'm a lot more concerned about mining operations, smelting operations, factories using these elements and spewing them indiscriminately in the air, especially in the third world. This is really causing metals to exist in the air that we're breathing. And when you're eating and drinking metals, and then you're breathing in the air that's very laden with metals, then you're really setting yourself up for this chronic low-grade exposure over time that is happening below your level of perception, which is extremely important, I think, for people to understand. You're being exposed to these elements really at a much higher rate than you've ever been before, but you have no idea that you're inhaling these elements, and there's a latency period for their bioaccumulation, in between their bioaccumulation and when they actually present or symptoms manifest. So that's another really pernicious aspect of metals toxicology that is not very well known either.
Yeah, I mean, it's really unfortunate because, when you eat something that's, got an exposure of heavy metals, at least you have some sort of protection from the gut. You can eliminate some. But when you're breathing it in, the lungs are incredibly efficient in bringing things from the outside directly into the blood. And there's really no buffer system there because, when in our evolutionary past did we have, aluminium salts in the air that we were breathing in?
And especially if you're breathing it through your nose, there's a direct pathway through the olfactory bulb for metal accumulation. It bypasses the blood-brain barrier even. So that is extremely, I think, dangerous. You can't all go live in the middle of nowhere, and I wouldn't even really recommend that. But in terms of that specific problem with metals in the air, I think of it this way. Whether or not they're using geoengineering for nefarious purposes, that's a different question, an open question. But there's so much being spewed into the air that we know about that's accepted. We could do so much to mitigate that. To give another example of this, gold mining operations are everywhere in Africa, and there are no controls on these operations. And in the gold mining process, you'll often encounter mercury, and mercury can get aerosolized through the processing and pulling it out of these rocks. So, what are we doing about that? I think we should focus on those things first that we can really deal with. I think that is critical to think about.
I love that you're so focused on solutions, and one of the main solutions you work with is actually using the elements that we do need, the essential elements, to help displace it and to help choreograph the way that this dance happens with the minerals in the body. And one thing that's interesting to me that we didn't talk about last time was the work of Hans Nieper and his understanding of the different ways in which elements can be bound to other molecules to exert different effects. And he was
Mm,
looking at, the difference between something like zinc aspartate and, zinc citrate and zinc orotate, and how all of these different molecules allow the zinc to end up in different places and exert different effects.
right,
And I
right.
know with you that the various supplements that are used
Mhm.
employ a different variety of these
Mm.
mineral moieties, so to speak. So, what are the different? Why employ so many different ones? Why not just elemental, magnesium drops or something like that to exert the
Mm.
effect? What is the benefit of having the variety of different mineral salts?
Usually minerals that are bound to like an amino acid, so like chelate forms, are
Mhm.
absorbed better in the gut. So that's number one. But then the distribution dynamics of these elements in the body gets very interesting. And this sort of goes to this idea of ionic mimicry and, let's say, non-substrate selectivity of certain of these molecules in the body that are responsible for binding and transporting these elements around. And um, just to give sort of a background on this, you have absorption molecules in your gut for many of these elements specifically, like zinc absorption molecules or iron absorption molecules. And these exist for the bigger elements, calcium, magnesium. Zinc and iron are trace, but they're the biggest of the trace, or they're the most
Mhm.
abundant of the trace elements. So the body has evolved elaborate mechanisms for absorption of these elements, right? And but with the trace elements, it gets a little more nebulous. There are non-substrate specific absorption pathways for many of these elements. A good example of this is divalent metal transporter 1, which can help absorb and transport many different divalent metals throughout the blood to different tissue sites. And so this is sort of speaking to how does the body reconcile or adapt to periods of scarcity, right? Because what goes on with these elements is that there may be certain of these elements which can work on certain enzymes and proteins, but other elements can work as well. And so this is actually quite useful from an adaptive perspective for the body. If you have like a deficiency or an inadequacy in one element, you can use another element as a substitute to put on this enzyme or protein so that you maintain catalysis efficiency, right? And so this idea that the body can use a bunch of different, or it uses these non-substrate specific absorption molecules is a very interesting one, and I think is very important to help explain how the body adapts to the differential intake of certain of the elements. You can use, let's say, multiple different elements on one specific enzyme. Zinc might be the preferred one,
Mhm.
but you can use maybe magnesium or manganese or others on that enzyme to actually continue life and continue that functioning of that enzyme. This explains to some degree why ionic mimicry happens as well, wherein the metals mimic or look like they have similar physiochemical characteristics to the minerals, right? So where the minerals can look like one another, the metals and the minerals look like one another as well. And we can think about this in terms of like electron configuration or other things, other parameters as well. And that's actually how the metals gain access to cellular compartments, is that there's a broad spectrum of very specific transporters for the bigger elements, but then there are more general absorption pathways for the trace elements. And the body, this is sort of like, it begs the question, well, why does this happen in the first place, right? It seems like an adaptive mechanism to prevent you from dying from one specific deficiency, right? And so that's good, but this leads to what we call ionic mimicry, where the metals can then gain access to cellular compartments through these non-substrate specific metal or mineral transporters. But there are also these very specific relationships that exist between the metals and the minerals as well.
Yeah, it's really interesting to think that ionic mimicry actually evolved as a beneficial aspect of our biology rather than just sort
Yes.
of a mistake. Yeah, that makes a lot more sense. And I presume that's why things like strontium and aluminium tend to be deposited in the bone because they mimic calcium function.
Yes. Right, exactly. And especially lead and calcium are very similar in size, ionic
Right.
radii, like 1.19 angstroms for lead and like 0.99 for calcium, or it might be the reverse. I can't remember exactly, but like the sizes are very similar. With zinc and cadmium, their electron configuration is very similar. Same with copper. But there's a lot of really interesting papers from like the 70s that sort of elaborated on this idea or this notion of mineral interactions in the first place. I think it was the work of a couple of researchers by the name of Hill and Matrone who theorized that metals and minerals with similar physiochemical characteristics would interact in biological systems. And then they proved it, basically. And especially with like zinc and cadmium, if you look at them on the periodic table, they're right next to each other. It's got many similar characteristics. Cadmium is very notorious for being able to utilize specific zinc absorption molecules in the gut. And when it comes to ionic mimicry, I mean, we can talk about the specific relationships between one element, one metal, and one mineral. But I think it gets even more interesting when we understand, and this goes to what we were saying just 5 minutes ago, that the metals can substitute or utilize many different mineral channels and transporters. So like lead has this very high affinity for calcium. And this explains why calcium or lead gets into the bones much more readily as a target organ than other elements. But lead can also substitute for iron. Lead can substitute for zinc. Lead can substitute for phosphorus and copper as well. So there's a broad range of affinities that the metals have for many different minerals. And this is actually, I think, one of the better arguments for why would we do mineral balancing for metal detoxification, right? It's because these metals are substituting across a broad range of minerals in the tissues, not just one element. And this is why, just taking one element to detoxify one metal might get you a little ways, but it's not going to do the complete job. And this, I had a really interesting case of a family from a couple weeks ago, and identical twin boys. Both have significant aluminum toxicity, but they have wildly different problems. One boy has tooth decay and bone problems and growth problems. The other one has intellectual delays and disabilities. This speaks to the distribution dynamics of the metals in the body as well. The metals can substitute for multiple minerals across different tissue compartments, right? And they cause different problems. So this is another reason why understanding metals toxicology is kind of complicated and seems like, well, why would these identical twins have wildly different problems? Their hair tests are almost identical. It was really remarkable. Their exposure vectors are all the same, right? They're eating the same diet. They came from the same mom. But the metals themselves, for whatever reason, and these dynamics are being elaborated on. We don't know everything about this or why aluminum might go into the bone versus the brain. But it's really my theory that with these two boys, aluminum for one of them got into the bones and the teeth, and the other one got into the brain. And so one of them has the intellectual issues and decrements, and the other one has these bone problems and growth problems and tooth decay. So that's another really interesting aspect of ionic mimicry and these dynamics, how these elements substitute for each other very readily. But when they substitute for each other in different tissue compartments, you will develop wildly different problems. But the idea here is that calcium being substituted for aluminum, or aluminum substituting for calcium in the bones, will cause these bone problems. Aluminum substituting for calcium in the brain will cause these intellectual issues.
It's so fascinating. I've been following you for quite some time, and you share some of these retests. It might lure you into a false sense of security when you do a hair test and then it almost shows up to, no heavy metals in the hair, you might think, well, that's great. And then, of course, you can infer heavy metals that are not coming out based on the patterns in the minerals that you see. And of course, 3 months after doing a specific protocol where you're consuming sometimes at super physiological doses of these elements, after 3 months of doing that, you see the things like aluminium, mercury, lead start to really be pushed out extremely quickly. And this is often accompanied by something like it's analogous or might be a Herxheimer reaction, which is basically a detoxification reaction where you don't feel very good. And I imagine there would be practitioners out there who are skeptical of doing anything that causes a Herxheimer reaction where the client or patient feels worse initially. How do you justify to them that this is all part of the process and that you're not just using that as a way to get out of the fact that it's not working or anything like that?
Right. That's a very important question. And I think I don't want to forget, let's talk about assessment of metals using the hair test. That's a very interesting topic. But to address this question directly first, there's a very specific sequence of detoxification that will occur on mineral balancing. We have to keep that in mind. Usually what will happen is when you're actually going through a Herx reaction or detoxification of a metal, you'll start to feel quite good, really, really good, as we give you supplements to balance the entire mineral system. That may go on for a couple of weeks, but then right after that, you start to feel bad. So understanding this sequence, right? Your body, the detoxification capacity is going up dramatically. When we replete the minerals in this strategic manner, right, you'll feel very good. And then it's sort of like, as that happens, you're mobilizing metals from tissue storage sites. These are the most toxic substances on Earth. So there will be temporary symptoms associated with their mobilization and that mobilization into the blood and through these excretory pathways. And this is really what we call a Herx reaction, but it's really understanding the sequence of detoxification. Whoa, I feel really good. Oh no, I feel really bad. That's a very good indicator that you're going through a Herx reaction. And then normally what will happen is after that Herx reaction, you feel dramatically better after that fraction of whatever metal has been eliminated, either from your brain or your bones or wherever it's being eliminated from. But this also speaks to the importance of doing retesting on our protocol, right? Because not only do we want to see the shifts that are occurring on the mineral side of things, but if you're eliminating a heavy metal and I'm saying to you, you're going through a Herx reaction, you will absolutely need and should demand and want validation that you're going through that process. And the hair retest helps us to validate that that's going on. The hair is connected to the skin. The skin is an excretory organ. So we can measure these eliminations, not totally, but in part when we do the hair retests, right? So understanding the sequence of detoxification and then also doing the retesting is extremely important for validating that, because that's a very good question. And I had that question myself when I started on this program many years ago. It's like, well, okay, I have a lot of people in this space saying it's just detoxification. That may be the case, but you need diagnostic validation of that. And that's why we do the retests.
Yeah, it's super important to actually continue to measure and see what's going on. Like you said, otherwise it's kind of pointless to do, 3 months and then have nowhere to go from there.
Right.
Diet is an important part of what you're doing, again, because it's critical to supply all of the essential minerals to the body. What I like about you is you stress the importance of consuming a lot of vegetables. And I think this is something that is sort of lost. I think this sort of meat and vegetable diet actually has quite a lot of validity, and it's probably the best way to really cover all of your bases. And I wanted to get your opinion about the things that are in vegetables that we might not know from specifically from, the
Mm,
USDA database, things like vanadium, things like, all of
mm,
these things that aren't measured in standard databases but are still present in vegetables in much higher amounts, or
right,
completely absent in animal foods.
right.
And also the importance of fiber, particularly given what you're doing with the program.
Mm,
I think the importance of fiber is often lost on a lot of people. And I think if there is
right.
ever a time in human evolution where fiber is most important, it's probably now, because we need our detoxification pathways, and
Mm,
that route is probably the most important out of all of them. So, what do you
mm,
see is the importance of consuming enough of a varied diet with lots of vegetables, and the role of fiber as well?
mm. Well, I think just on this point of eating meat and vegetables, or animal and plant products,
Mm.
we're omnivorous.
Yeah.
Human beings are omnivorous, and so we're in sort of a nutrient milieu that's very degraded if we compare it to 100 years ago. And so I think that behooves us to consider that we should be getting as much nutrients as we can from whatever foods that we can nowadays. And that is probably the most important thing to consider above everything else, above oxalates and other potential plant poisons, those are valid ideas and valid concepts. But if you exclude a broad or an entire food group, let's say just animal products, that's a disaster, because you're not getting zinc and phosphorus and iron and taurine and B vitamins. But if you exclude plants as well, you're excluding a lot of the alkaline reserve minerals, like magnesium and potassium, especially manganese as well, right? So I think first understanding that human beings are omnivorous, and the nutrients that are in plants and animals are quite complementary, right? So iron and manganese work together, copper and zinc work together, calcium and magnesium work together, and these are found in animal foods and plant foods. So I think just taking that common sense approach is very important, but then understanding that the trace elements are really difficult to come by now, and they're in a lot of plant foods, especially vegetables like rubidium, vanadium, silicon, which we are sort of figuring out what these elements are used for. In my opinion, they're in many cases used as activators for the larger elements. Like there's some interesting research looking at how silicon helps calcium metabolism and bone metabolism. And there's been some interesting research looking at like racehorses and supplementing them with silicon, and how the higher silicon groups, they not only run faster, but they're less prone to injuries because of this idea that silicon is helping calcium in the bone tissue, right? So, but a lot of plant foods, in particular vegetables, are much more nutrient dense than, let's say, like fruits, as an example, which many of them are bred for sugar and size and aesthetic purposes nowadays than anything else. And so I tend to think of it from that perspective, where the plants especially are a very good source of these hard to come by elements that we don't actually really have a lot of data on, right? And you had mentioned this, like lithium, rubidium, vanadium, silicon. There will be more to come out in the future, I'm sure, and the interactions that exist between all these elements. But it behooves you, I think, to get some minimal or sufficient threshold of those elements. And I think that we can ensure that if you eat plants and animals, it's less clear what will happen over time with these subclinical deficiencies if you just do carnivore or if you just do veganism, right? So I think carnivore is, worlds better than veganism for sure, right? I think we can see a lot of those overt deficiencies play out much more rapidly in veganism than we can in carnivore. But like deficiencies, these subclinical deficiencies are hard to measure and they happen slowly over time. And then you have metals bioaccumulating or at the same time. So you want to ensure sufficiency on a daily basis of all of these elements. And the best way to do that is through an omnivorous approach, I think. And, I don't want to leave dairy out of this situation. I think raw dairy, high quality dairy is one of the best foods on the planet, like by far. So when you eat a diet that's based roughly on this, lots of high quality animal foods, high quality plant foods, and dairy as well, it's hard to go wrong, but you'll also ensure, I think, sufficiency of these elements, which we're less clear on what they do and the potential negative consequences of not getting them.
Yeah, it's funny. It's actually not all that easy to get enough calcium if you leave dairy out of the equation. And I've found raw cheese to be quite helpful in my own situation, because it's quite difficult to get raw milk or anything like that here in Australia. But yeah, I mean, what if it's there, why not use it? I mean, particularly if it's a really nutrient dense food and it's not causing you any gastric distress or anything like that, then there's no point, there's no reason why you shouldn't use something that's potentially so beneficial. Now, you mentioned Chris Eckersley and you're drinking the Fiji water, so we better get into silica and silica-rich water and the potential use of that to ameliorate some of the issues with aluminium toxicity.
Yes. Chris has demonstrated I think he's done this firsthand. I can't remember if it was him in his lab or other researchers who've demonstrated this, but they've shown pretty high levels of aluminum excretion through the urine when they give the silica-rich water to like Alzheimer's patients. So this sort of goes back to this idea of ionic mimicry, and these elements sort of substituting for one another and displacing each other. But Chris has been at the forefront. For whatever reason, he's not super well known in the alternative health space, but he's, I mean, in my opinion, one of the best researchers that there is on the planet to understand, especially dynamics of aluminum and silica. And so there's a lot of foods that are rich in silica, but it might be slightly different with the waters where there's a very specific form of silica that is formed after it runs over these rocks for a very long period of time, and it's called orthosilicic acid. And it's important because it's much more soluble and it gets into the blood much more readily than some other forms of silica. And so if there's aluminum in the blood, it can sort of displace that. And it may have an easier time getting into tissue compartments as well because it's so soluble. So, but like waters like Fiji, Acylus, there's another sort of niche brand called Aquene Springs in northern Idaho. These can help be a very good source of bioavailable like silica, and that can help to some degree to displace aluminum in the kidneys or maybe in other places. It certainly can help when it's in the blood. But that research has been, I started reading a lot of his papers in the last year, but then he has a book that came out in 2020, which is also extremely good. And I would recommend everyone read that. It's a very good read for lay people. You can understand, it's not like a technical paper or anything like that, but he lays out the case for not only the importance of drinking the silica-rich water, but how ubiquitous aluminum is in the environment and how it's really actually causing many of these modern health problems that are hard to deal with.
Yeah, I feel quite bad for Chris because he got embroiled in controversy because his papers were essentially saying that the childhood vaccine program was at odds with their recommendation for tolerable limits for children and aluminium exposure. And he was basically saying, well, your own recommendations aren't even being upheld with these schedules. And he was just asking the question sincerely, and he got absolutely crucified over that, which is a real shame because he's a very genuine researcher, and like you said, he's been around for a long time, and he really is the expert on this. And I presume that using a silica-rich water
Mhm.
alongside a mineral balancing program is going
Yes.
to be the best way to do it, because then you are mobilizing the stored aluminium and also you're able to excrete it with the mimicry. Um, I've heard some practitioners say that all you have to do is get silicon dioxide,
Mhm.
put it in water, and then you have a silica rich water. Um,
Mhm.
from what you've just said, it might be a little bit more complex than that with the interaction with the water running over the rocks and creating these unique compounds, not just the silica itself.
Exactly. It is
Right.
the orthosilicic acid that is formed, and it's quite specific. And there are a couple of videos. I think Chris talks about this in the book, but there's a couple of videos of him explaining that, because there are questions that he gets as well, from a lot of different people in some of the Q&As that he's had, and talks that he's had as well. But yeah, it's not quite as simple as just taking silicon dioxide.
That's really interesting. I know a lot of people would be really interested to
Mhm.
know how to sort of liberate and get rid of the heavy metals. So, um,
Mm.
how can people get in touch with you and sort of learn a little bit more about this mineral balancing thing that you're on about?
Yes, absolutely. So the best way to get in touch with me is probably by direct message on Instagram. I'm all lowercase, nutritional underscore analytics. And that's the company that I founded many years ago now to help run hair testing and engage in these mineral balancing protocols. But that's the main place. I've got a website, but that's more of a portal for clients to order hair tests and the mineral balancing packages. That's nutritionalanalytics.com. And then my email is just Clark, CLARK, at nutritionalanalytics, all lowercase. So any one of those, usually email and the Instagram are the best ways to do it.
That's awesome. I will make sure to link all of that, and I'll also link our first conversation because I think this one sort of lifts off from where we started in the last one. So it's probably a good idea to have listened to that one first. I think this is a great way to wrap up. We've covered quite a lot, and I think this helps make sense of what we're talking about here with systems
Mhm.
biology and how well this sort of ties in with this idea of the human body as this complex interconnected organism rather
Mm,
than just numbers on a page from a blood test. Um,
exactly.
so hopefully this can get a bit more traction because I'd like to see, like you said, a little bit more sort of research and intensive, use of this to see how useful it can be and get some more people onto it to get their opinions. It seems to be still quite niche, but a lot
Mm.
of people seem to be interested. So thank you for everything you're doing. I hope you all of your clients seem to be very very happy with the results that they're getting, which
Mm.
often is much better than any randomized control trial that you can run.
Right. Right. Yeah. Working in the field and that the clinical results that we have are quite remarkable, So to me, at the end of the day, RCTs are very important, and actually doing that work is extremely important. But at the end of the day, right, does something like this work in real people? Um, it could take another 1,000 years to actually demonstrate that with the way that the scientific system works now. So is it perfect in terms of that? Right? Can I cite a specific RCT or other studies which are looking at this approach? Number one, there's no funding for that. But number two, it's extremely difficult to design a study to reflect the complexity of these interactions. There is a field of research for people that are interested. I would point them in the direction of ionomics. There is a field that's developed in the last many years where there are a lot of papers that are being published elaborating on the interactions between these elements. And Dr. Eck kind of stumbled on these clinically and just trial and error many, many years ago. But a lot of this stuff is being elaborated on in the literature. So if anyone wants to dig more deeply into mineral balancing, check out ionomics. A lot of these interactions are also elaborated on in metals toxicology textbooks and papers. So that's an interesting place, I think, for people to look. But if we have a little time, I'd love to talk a little bit about how we use the hair test to assess metals. This is, I think, a very oft misunderstood domain, especially in people who are doing hair testing. They don't really understand how to look at the test through the lens of these interactions, how the hormones affect detoxification pathways, but then also high and low levels of certain of the toxic metals can have a similar meaning. And so like I would like to kind of set the stage for this and say that when we use a hair test, we're only measuring the deposition of the metals and the minerals into the hair tissue. And we can use that information as sort of a proxy or a biomarker for heavy metals in the body. It's not a direct measurement. So I hope that people understand that, number one. But when you understand these interaction dynamics, you can really use it like a probabilistic determination model, basically, where like if a certain mineral ratio is off, and let's say the metabolic patterns are a bit off, and like a specific mineral is very low, you can correlate that to toxicity of a heavy metal, even when that metal is very low in the hair tissue, right? So we're sort of using this, our knowledge of nutrient, mineral, and metal interactions to do a deeper analysis on the metals than just looking at the individual metal levels themselves, right? And it is a probabilistic determination. We can't actually go into the body and do a full reading of the metals in every tissue compartment. No such test exists. We have to use like hair testing and urine testing and blood testing to get that complete picture. There's a lot of advantages to using hair testing because it's a stable biological tissue that we can use to measure chronic exposure, since the hair is a more long-term tissue to measure, right? And that I think is much more important for the general population because not a lot of people are being acutely exposed to metals in an occupational setting. So doing a blood test for metals is very insufficient unless you've been acutely exposed.
Yep.
Right. Urine testing can be quite useful to measure maybe kidney status of the elements and maybe what you're excreting as well. So there's a lot of different dynamics that play into this when we actually do the hair analysis interpretation of the metals. And there's another really interesting phenomenon that I think you mentioned before, this pore eliminator idea, or the pore excreter theory that sort of got traction and was elaborated on in literature by looking at autistic kids in the mid and early 2000s. And so a lot of more honest research was being done at that time. And researchers would notice when they would do the hair measurements of the metals in the autistic children versus controls, the autistic kids had much higher levels or much lower levels of metals than the non-autistic kids. And so this was sort of throwing a wrench in maybe this idea or theory that autism is not caused by metal toxicity in the brain, but a lot of follow-up research, especially Chris's work, has actually demonstrated without a shadow of a doubt that like aluminum in the brain tissue of autistic children is extremely high, right? So there's sort of a discrepancy there that exists. And how do we explain this? Where brain tissue levels, direct measurements of brain tissue of aluminum, very high. In the worst of those autistic kids, the metal levels in the hair are very low. The way that you explain this is by understanding that metals inactivate detoxifying enzymes when they get inside of you beyond a certain threshold.
Yeah.
And it's sort of another higher level principle of metals toxicology that's not very well elaborated on, and no one really understands it unless you're reading these textbooks or writing them, for that matter. So that is really another, I think, interesting idea or concept that we can kind of discuss when it comes to interpretation of the hair test, and one of like the higher level ways that we use to do a deeper analysis of the metals when we actually read your hair test. That can be sometimes hard for people, right? Because metals are not something that you're accumulating, and it's quite intangible, right? But so that can be difficult. But like when you have very low levels of, let's say, zinc or selenium, those elements are very important as buffers against many different toxic metals all at the same time. So when you sort of put the pieces of the puzzle together here, and you've got low zinc and low selenium, and the metal levels are in this pore eliminator range, and then you have these metabolic imbalances, we're sort of putting a lot of pieces of evidence together along with your exposure history That's another really important part of the assessment. And so we can put all of these variables together and do a probabilistic determination of your potential metal toxicity burden. We're still having to do this because we don't have good enough tools to actually do like a full body scan of your metals in your tissues. So, but the hair test is phenomenal at when you understand it correctly and the interaction dynamics. It's phenomenal for doing a really high quality assessment of your metal toxicity burden.
Yeah, it's fascinating that you can infer metal toxicity based on the other levels of the minerals that you're seeing. And again, what you were talking about with this pore eliminator theory exactly matches this concept of cell-use stress response, and this basically reaching a threshold where organic disease becomes chronic disease and the body can no longer cope. And that it matches perfectly with what you're talking about, where there comes a point where you accumulate so much that it actually inhibits your ability to stop accumulating it, and then once that threshold is reached, that's when you see chronic disease manifest. It's really interesting.
It really speaks to this idea of adaptations as well, and Cellier talks about that. Right, the body goes through these different phases of the stress response, and there are specific adaptations that have to occur to sort of keep you going. Right, and that happens when you get exposed to metals. And Chris Exley talks about this quite a bit. Your body has exquisite mechanisms for adapting to the presence of these toxic metals over time. But when they go beyond a certain threshold, your body ceases to have the energy to adapt to the presence of these elements. And then you start to develop symptoms and full-blown conditions and diseases. And a good example of this is like aluminum substitutes for magnesium in ionic mimicry. And when it does that in the brain, it can lower or affect energy dynamics because magnesium is very important for ATP enzymes, right? So you can actually lower and really affect not only synthesis of ATP, but its distribution, and your energy level will literally be lower as a result of this aluminum toxicity. And your brain will have to adapt to the presence of this and work harder in other regions to deal with like the presence of aluminum in, say, your prefrontal cortex. And the adaptations, right, this, especially with the energy dynamics, you lower energy, you end up with brain fog or something kind of subclinical that you go, well, this is maybe just aging, right? But if that goes on for long enough, you'll end up with Alzheimer's or dementia. And then layered onto this is the time cycle idea. If these adaptations occur, right, and they're left unchecked for long enough, over a long enough time cycle, that's how diseases develop. It's not a simple insult, one thing, right? You have cancer one day, the day before you didn't have it. No, it took 20 or 30 years to develop.
We are a complex system beyond what we will ever be able to understand. And right. I think what you're doing is kind of admitting that, but going, hey, we can understand it enough to know how to help.
Exactly.
And like I said before, it seems like a lot of the people you work with, if not all of them, seem to have really, really good results and trend towards the right direction, which in a world that's so toxic and messed up at the moment is probably the best we can really hope for.
Right.
Yeah. So,
I also want to mention quickly, because I would be loath to not mention it. So Dr. Stillman would kill me. We do have I've been working with Dr. Leland Stillman for about a year, thanks to you introducing me to him. And that's been a really cool working relationship that we've had. And we're doing a lot of group coaching now with clients. And we're opening up group coaching a little more coming up in the next month or so. And we're also opening up our practitioner training program again, which we kind of put on hold for a little bit. We started that maybe about 6 or 9 months ago. We went through a couple of cohorts and realized we wanted it to be more rigorous and have a really good exit exam for practitioners. But we're opening that program up again. We're going to do group coaching, and we have an HTMA course, video modules on Kajabi, which I think you've been able to check out too. But we're going to be reopening a lot of that in the next month or two. And so I'm really excited to do that with Dr. Stillman.
I will make sure to link all of that as well, and make sure people who are interested in actually learning how to read and interpret and use HTMA do a course like this, because it's so important to really understand what you're doing.
Right.
Because it's not, like we said, it's not a linear system where, this is low, therefore take this. It's not like that. You really have to understand the nitty gritty. And that's something that I've yet to wrap my head around at all. So, it takes time. And fortunately, you and Dr. Stillman have worked really hard on putting this stuff together. And I'm really grateful that I put you in contact, because you guys have been have been on fire the last year or so. So, super happy. And I will make sure to direct everyone there.
Cool. Awesome, Cameron. Thank you so much for having me again. This has been great once again.
Thank you so much for listening to this one. I really hope you enjoyed our conversation. I've left many links to Clark's work in the episode notes if you'd like to learn more about him and what he's doing. If you'd like to support the podcast, please subscribe, leave a positive review. This really helps me reach more listeners and get more interesting guests on the podcast. If you'd like to keep up with my work, I've left links to all of my social media platforms in the episode notes. Thanks again for listening, everyone. Take care.